All right, so let's do some more difficult proofs now. Now we're going to show that if x is an even integer, then x squared minus 6x plus 5 is odd. So let's first look at our proof, do some cases. Let's give some examples, right? So let's try some even integers. We're going to plug in x is equal to 0. So if x is equal to 0, this is going to be equal to 0 squared minus 6 times 0 plus 5, which is equal to 5. So yeah, 5 is in fact odd and 0 is even, so that's true. Next, let's do the next easiest case. We're going to do 2. So x is equal to 2. We're going to get 2 squared minus 6 times 2 plus 5. This is going to equal to 4 minus 12 plus 5, which is simply going to be equal to negative 8 plus 5, which is negative 3. And negative 3 is in fact odd. Okay, so I'm going to go off the premise that this is probably true, so let's go ahead and try and prove this. So the first thing we should notice is that this is probably a for all proof, and the reason I'm saying that is because we're saying any integer, any even integer x. This doesn't say there exists or there is. Usually that would be stated in the statement, so because it doesn't say that and it's just not putting any restriction on our x, this is probably a for all proof. So let's write that down real quick. Right, this is our statement that we're going to try and prove. Okay, so let's begin. What do we do? This is a for all, so we're going to start our proof with let. So we say, let x be an integer. Next, we also suppose our p, right? This is not with the then. Our p is that if x is even. So we're going to say x is an integer and x is even. Let x be an integer and x is even. Oh, actually, let's write that a little nicer. Next, we need to define what we mean by even when we say x is even. So let's say then x is equal to 2, let's pick a random letter j, 2j, where j is an integer. Okay, awesome. Next, we're going to plug this in and show that if this is true, this is going to be odd, right? We've supposed our p, now we need to show that we're going to try and see that q is true. So let's do that. X squared minus 6x plus 5 is going to equal to, now we plug in what we've defined x to be. So then from here, let's try, and I can't really see how we can directly get something in the form of 2 times an integer. So we're just going to expand this to be 4j squared minus 12j plus 5. Okay. We need to show this is odd. How can we do that? Not so easy right now. Okay, what I'm thinking we can do is we can factor out a 4 here, or no, we'll factor out a 2 here. Yeah. We need something as a plus 1. Usually that would be great. A 5 works too, but then we would need to justify that an even plus an odd is always going to be odd, which maybe we'll end up doing that proof. Anyways, let's give this a shot. Let's just factor out a 4, so we're going to get, or 2, sorry. We're going to get 2 is 2. Oh my gosh, my marker is dying. How can we get it to look like an odd number that we know? We could just split 5 up, I'm thinking, into maybe something like 4 plus 1, and then make 4 into an even number. Oh, I got it. Actually, yes, that would be really, really good. So I'm actually going to go back a step. This is perfectly okay. What I'm going to do is I'm going to split 5 up. So this is what we're going to get. 4j squared minus 12j plus 4 plus 1. Right, this is the same as 5. But now what I can do is I can factor out 2 here and still have a 1 at the end to make it look exactly like our definition for an odd number. So what we're going to end up getting down here is going to be 2j squared minus 6j plus 2 plus 1. Okay, we got it. Okay, awesome. Now all we have to recognize is this here is just any integer, even or odd, we don't care, multiplied by 2, and then you add a 1, which is our definition of an odd number. So then we say, where 2j squared minus 6j plus 2 is an integer. Now let's conclude our proof here. Since 2j squared, oh actually no, let's go back. Since x squared minus 6x plus 5 is equal to 2j squared minus 6j plus 2 plus 1, where 2j squared minus 6j plus 2 is an integer, x squared minus 6x plus 5 is odd when x is even. Awesome. So we've just proven that this statement is in fact true.